All right, hello to another inheritance lesson, chapter 9. Before I get into the new lesson, I want to go over if you made an array list with questions, right? So we were working on those question projects. So if you made one that had question objects in it named questions, try to see if you can do a loop that would do display question for each of the questions. All right, so pause the video, sketch out your plan here, and then see how it goes. Okay, so certainly you could do an enhanced for loop. Maybe I'll show the code for that in a second. But if you want to do the regular loop, you just start with int I as 0. So start at question position 0. I is less than questions.size. Okay, so just stay below the size plus I. So that'll loop through each of the indexes in the array list. And then for each one, you get that question. So I'm going to do question q equals questions dot get position I, so get the ith one, and then now that I have the question, I can do q dot all the methods that I have in question. Right, so the ones we want to do is just display question, which didn't take any input parameters, and we just do a system out print of that question. All right, so that is what it would look like. Kind of a cool trick, right? Like once we have our own custom variable types, you can put them in an array list, and then we could run them all at once, like run a quiz all at once just using one loop. The enhanced for loop would just be for and then question q pull from the questions array list. So it would look like that. So it essentially do this line for us right here, the get line, and put it in queue each time. And then the rest of this would be real similar. I would just call q.display question. All right, and again, I like the enhanced for loop quite a bit. To me, it's simpler, cleaner, but certainly you can do it with regular loop if you so choose. One other note here quick is as we're getting closer to the AP test, this is a pretty good book for reviewing. It has a lot of practice questions. Obviously, we'll do a lot of stuff together in class, but if you want a book, this is one that I think is pretty decent. And honestly, the online AP site is so good now. They have so many practice things in there that I think you have access to. You could always, look over that stuff. And obviously, I'll assign some of those as the date gets closer. But I just wanted to mention this book in case you are interested. All right, so today we did polymorphism from before, all right, but except we're going to do it now with inheritance. So if you forgot what the word polymorphism means, they have like a fancy definition up here. But poly, again, just means many, right? So poly means many, and morph means like to change. So basically, you could have like a word have multiple meanings. So the example here, like the word bear, could mean like a bear in the forest, like a grizzly bear, brown bear or something, right? But it could also mean like I can't stand it anymore. I can't bear the load, the burden of hearing Mr. Westphal's jokes. So you can sort of tell by the context what is the meaning of bear, right? So in Java, in the same way, right, we can do like a get area method, right? And then Java will know based on the context. If it's like a circle, it would do the area one way, and if it's rectangle, it would do it with a different way. So this get area could morph into two different area things depending on what type of shape it is. Okay, so yeah, it's just the same method, but has different behavior depending on the type of object it is. Okay, and so we're going to show how to do this with inheritance. I did find this video. It's kind of creepy a little bit, to be honest. I'm not going to lie, but I thought it was a good picture of like what it means, like polymorphism means. So it just means like you can morph into different things on the fly. So I think this just is just like a video of, I think, like people just morphing into different people. So like the code can just morph from one thing to another, right? So as weird as this is, I think this is a good way to think of polymorphism, is it can just change from one thing into another. Okay, that's enough creepy weird video. Okay, let's see. So we're going to do an example, and we are going to do inheritance again, where we have shape as like the parent or superclass, and then we have rectangle and circle as special types of shapes, subclasses or child classes. Okay, and then we'll have a fourth.java, which will be the runner that'll have a main and that'll create instances of this. Okay, so much like before, shape, the only really thing it's going to have, the only variable it's going to have is name, right? Basically, I would have radius, but that's only specific to a circle, and I would have like length and width, but that's only specific to a rectangle, right? So shape, its specific thing, its only thing it's going to have is just name. Okay, and I'm also going to make a method, so that's the data. As far as methods go, I'm going to do a public void method that does who am I. All right. And then rectangle, circle, the way they're going to be different is they'll still have a name like circle or rectangle. That's still true. But then this one will have a radius. Okay. And then a rectangle will have two double variables, one for length and then another one for width. All right. And so what I want to talk about here is the idea of how we could have like this method, who am I? I could, overwrite it down here and then have it do different things based on the shape. Okay, so I'm going to do two methods. One is public, the who am I one. So I'm going to implement it in circle and I'm going to implement it in rectangle. So it's going to overwrite it. And then what I'm also going to talk about is I'm going to do a get area. Okay, so get area is going to be different for each one of these. So I'm going to do a public double get area. That's going to calculate the area for the circle. And then I'm going to do the same thing over here. Okay, and it would sort of make sense to like have it up in shape too. All right, because every shape should have an area. It's just the way you calculate area is going to be different depending on the shape. Okay, so I'm going to put it up in shape, even though a shape itself, we might not know how to get its area, right? We're still going to put it here just because all of our shapes are going to have an area, right? And we'll talk a little bit more about that later in the video. Okay, so that's roughly the setup. And I'm going to do most of the coding here. If you wanted to code it with me, you could, but really, I think it's better for you just to try to make sense of this and the value of doing polymorphism with inheritance. Okay, so here's our shape class, and it's just basically got the name variable, and then it just has a constructor that sets the name coming in. And then I'm going to do public void who am I. Okay, and I'm just going to sys out print I am a boring shape. All right, and then the area, right? So actually, I'll come back to that area method here maybe in a second. All right, so circle and rectangle. All right, I have my radius in circle. I made it extends shape. Okay, and then I'm going to do the constructor where it passes the double radius in. But the tricky part is I also want to set the name, right? I want to set this name variable to be circle. All right, so I'm going to see if you can figure out what would be the right code that goes here. All right, because I don't want you just watching. I want you to pause the video and see what would be the right code here. If I want to set my two instance variables of radius and then the one up here in shape called name. I'm sorry, to help with this, I'm going to do a little split screen action. I think this might actually be kind of helpful. So pause the video and see if you can do the right constructor here. All right, so down here, I want to call super and just pass in circle, my name of circle. So that'll set this name variable right here using this constructor. All right, and then I'm just going to set the radius, in. Okay, and I'm going to overwrite the public void who am I. So I'm just going to make a note that I'm overwriting. Might only be one T here, probably. All right, overriding the method. Remember, this one just says I'm a boring shape. So I'm going to talk some smack. Circles are very cocky. So I am circle much better than that loser rectangle. Let the tracks talking commence. Okay, so they're going to say something quite a little bit different for who am I. All right, let's take a look at rectangle next. So same two things. It extends shape, right? And I'm going to ask kind of the same question of should we do for this constructor here, right? What would make sense for the constructor, and then what would make sense for a who am I method for the rectangle? Pause the video, give it a shot. Okay, so I'm going to call the superclass constructor and just pass in rectangle. So I'll set this name to be rectangle, and then I'm just going to set length and width to be the ones that came in. So length in and width. Sorry, it doesn't quite fit on the screen here, but there's another variable called width in. The width coming in. Set those. Okay, and then I can do public void who am I. I'm just going to override it with I am rectangle. Circle is mean to me. Alright, because circle's always talking smack. Okay, so now that I've made these classes, set them up. I haven't done the get area yet. We'll come back to that maybe in a second. But now I'm going to do the runner, right, and kind of show you why this is sort of valuable. So I'm going to go to runner, okay, and what I'm going to do in runner is make an array list that has shapes in it, and then I'm going to add to it, right, since I can store any type of shape, right? That's kind of the cool part of inheritance is any of these shapes I can store in there, right? So basically, because circle is a shape and rectangle is a shape, I can put it in this array list of shapes. I don't have to make a separate one for circles and rectangles. All right. I'm going to add them. Maybe I'll add one more. I'll do shapes.add. I'll do one more circle, even though they're the bullies. A little bit bigger radius this time. Okay. So now I can do a for loop. So I'm going to do for, and actually maybe you should try this, right? And I just want to print out the who am I for each one. So see if you can figure out how would you print out or run the who am I for each shape. All right, so see if you can figure out the code that would work there. All right, I'm going to go enhance for loop again. So I'm going to just do shape s from shapes. Maybe I should call it shape. That's a little bit better. Pull it from shapes. And then I'm just going to call the shape dot who am I. Okay, and so it'll morph automatically into the right who am I method based on the type of shape that it is. Okay, so that's kind of a cool thing is that I can store a bunch of shapes in one array list and then I can run this. I don't have to worry about like which shape it is and running a different method. It just knows to run the one based on the type of object it is. It morphs kind of on the fly. So you can see that the circles are saying they're circles and taunting rectangle and rectangle saying that circle is mean to me. Okay. So that's kind of an example, a good example of where inheritance and this idea of polymorphism can be useful, right? As we can make a single array and store multiple different types in there. One more quick example from the last project we were working on is you can start to see where this would be kind of useful where I have my questions and I can make an array list with the question type here, and then you can put in there any type of question. So you could put in a multiple choice question, a numeric question. So you can see I put the different types all in the same array list because they're all questions, and then I can loop through and do my present question and everything from there. Right, so it's kind of a neat way to like store them all, and it works because this is the parent class, and then Q2 and Q3 are subclasses of that.